Hello, everyone, and welcome to the first Cosmos webinar. I am super excited to have you all here. And today we have a fantastic speaker with us. My name is Jonas Rosland. I am the Director of Community here at the Cosmos community. And today we have Sumit Paul, who is the Strategic Technology Director at OnToText. And Sumit will tell us all about knowledge graphs and LLMs, how to enhance LLMs together with knowledge graphs for external knowledge, and also to reduce hallucinations done by LLMs. This is a very interesting topic and something that I'm very interested in personally as well. So I hope you all enjoy. Some housekeeping. If you have anything that you want to ask, please use the Q&A. You can discuss in the chat as well throughout the presentation here. And with that, thank you, Sumit, for being here to present today. Take it away.
Hello, and welcome, everyone. Good morning, good afternoon, or good evening, based on wherever you are. Thank you, Jonas, for the introduction, and thank you, the vast Cosmos community, vast data team, to give me this opportunity to discuss about this very relevant topic today about knowledge graphs and LLMs. So a little bit about myself. I have been doing graphs since last millennium. As a part of my bachelor's and master's in computer science, graph was something that always excited me. I am an ex-Gartner analyst. I was with Gartner for about 5 years, advising enterprise architects as well as CXOs on data management analytics. Prior to that, long time back, I was also a kernel developer at Microsoft SQL Server team, as well as Oracle's OLAP engine. And then I worked for about a couple of years at Verizon as a big data architect. And then I took a break and worked for about 5 years for myself, where I did a lot of hands-on implementation with data lakes, lakehouses, a lot of SQL engines. And during that time, I published this book called SQL Engines on Big Data in 2016. It's an outdated book now, but the fundamentals still apply. And also developed an online course with this company called Experfy. And I've been with OnToText for about a year and a half. My role is the designation is a pretty scary sounding one, strategic technology director, but I tend to do a lot of multiple things, from thought leadership to evangelism with knowledge graphs, as well as doing hands-on implementation, solutioning, and helping generate new content and help the pre-sales team to help prospects understand the value of knowledge graphs. So these are some of the things that we will cover today, a very brief intro to OnToText and about introduction to graphs and knowledge graphs, and then we'll dive into the meat of the topic around knowledge graphs in the enterprise and how it helps with LLMs. So OnToText has been a global leader in the graph database space, especially in the RDF space, in the RDF graph model space, for building and managing knowledge graphs, for doing knowledge management and content analytics. OnToText has been in business for almost about 24 years. It was started as an R&D company by the founder whose PhD was around knowledge graphs. And one of the distinguishing features of OnToText's graph database is it is based on semantic technologies, the same fundamentals on which Dr. Tim Berners-Lee founded Internet and the semantic web, where data is connected across different systems. And that's one of the major reasons why knowledge graphs help you in bridging data silos, connecting and interconnecting different data sources. OnToText is based out of Europe as well as in US and APAC. A lot of big enterprises tend to choose OnToText's graph database engine for powering their enterprise data management systems, especially relevant in the field of finance, in the field of life science, where there is a lot of unstructured data that is across lots and lots of different systems. We also have a lot of customers in the area of energy management, from electricity to oil and gas, as well as customers in the publishing area, where there are a lot of unstructured data. Very recently, since about 8 months, OntoText also has got a lot of traction in the AI space and in the space called the graph rag, where we rank on Google on these search terms with the ranks, as you see. We have done a lot of innovative cutting edge work to bring in and enhance RAG with graph RAG capabilities, developed our own entity linking capabilities with very high throughput and very low latency. So you can check out our LinkedIn page and join the Graph and AI in Action group. So let's take a quick look at what graphs and knowledge graphs are. For those of you who don't have a good idea about graphs, we use graphs every day. We just don't realize it. The moment you use GPS, you are under the cover using a graph data structure. All of social media is all about connectivity, about connections between different people. And that is basically graph. Again, when you are using your cell phone, and as you are moving from one zone to the other, these cell phone towers help you to switch. The technology for the cell phone tower help you to switch from one cell phone tower to the next. And that is also under the cover, powered by graphs. The whole supply chain, transportation industry, a lot of things in the data management space, for example, lineage, master data management, and even for those of you who are database experts who do transactional databases, under the cover, transactional management, preventing deadlocks and things like that are handled by graph data structures. And there are lots and lots of other applications. We also use knowledge graphs every day. We just don't realize it. The moment you use any search engine today, whether it's Google, whether it's Baidu, whether it's Bing, you are using a knowledge graph. The whole idea about knowledge graph was sort of more publicized when Google in 2012 sort of changed or altered their algorithm for doing search from inverted index, plain inverted index, to using knowledge graphs. We are in this era where keyword-based search does not matter anymore. It's more important to do what is called as concept-based search or semantic search. That is when we moved from searching with strings to searching with things. And that is what knowledge graph brings in. For example, when you are in a search engine and you start looking for, let's say, Albert Einstein, right? You go to Google, you get a list of results on Albert Einstein. On the right-hand side, you will see a lot of other information about him, where he was born, where did he study, who are his family members, and things like that. That comes from Google's own knowledge graph. Knowledge graphs also have got a lot of attention from Gartner over the last about 10, 12 months, where knowledge graphs are now the center of attraction in terms of using it specifically for LLMs. And here you see knowledge graphs is at the center with a very quick range in the impact radar for the next year to year and a half in terms of how it can help organizations become AI driven with the Gen AI and LLM sort of technologies. Now, what are the problems basically a lot of enterprises face today? Exploding dataverse, right? Data is growing at an enormous pace, and I call it data obesity, right? We have so much of data all around. We just can't understand what is going on with all the data across different data silos. And the failure to sort of connect the data across these different data silos is very challenging for enterprises. Before LLMs, organizations continuously struggled using unstructured data. Unstructured data is an umbrella term for text data, for PDFs, for blogs, for emails, for your content management system, even with audio, video, and images. Using that was very difficult for a lot of enterprises. And a lot of the data is siloed across different departments, business units, different regions, different data centers. And findability of data with all this has become extremely challenging. In fact, in 2022, McKinsey and IDC did a study where they found that 30% of the time for most employees in an organization is spent just searching for the data, just looking for the data and getting access to the data that they want to use. So these are challenges that all enterprises face. And this is a picture which I call the DIKW picture, which is the data at the lowest layer. Then we have information, knowledge, and wisdom. And most organizations remain in that information layer because they fail to apply context and semantics properly. And you can see this very clearly if you ask yourself these questions. Why do a lot of the data lake implementations fail? Why data is getting increasingly difficult to find? Why do existing data catalogs do not work in large enterprises? Why do LLMs hallucinate? And the answer to all this is the lack of context, the lack of semantics, which is why a lot of organizations are now looking to leverage the power of knowledge graphs, the power of connected data, data that is connected semantically, not just through foreign keys as in relational databases. And this is the reason why knowledge graphs are getting a lot of traction now, where knowledge graphs help you to connect the data in a semantic way across different data silos. It helps you with things like semantic alignment, interoperability, with standards. Why standards? Because knowledge graphs built on the graph model with RDF graph supports the Web3 standards of semantic web that allows you to connect data sets in a very standardized way. Now, what is a knowledge graph, right? I've been talking about knowledge graph. So what is a knowledge graph? A knowledge graph is a structured, think about knowledge graphs as being a structured representation of knowledge that is within an organization, from a domain knowledge, from tribal knowledge, where entities are represented as nodes that are connected by relationships. And knowledge graphs excel at capturing this information and organizing, providing a structure to this knowledge, which is both human consumable, human readable, and the other aspect is it's machine readable. So a knowledge graph gives you a semantic representation of your domain data. Rather than just storing data as rows and columns, it stores the data, it represents the data as a connection of concepts and relationships. That is where you get a lot more power. And knowledge graphs we as human beings have these knowledge graphs in our head where we can relate things quickly to a concept, but a machine cannot unless we put in that data. And knowledge graphs, with their interoperability capabilities, and I'll show you with an example, can quickly bring in new concepts and link those concepts to your existing instance data. And this forms what is called as the knowledge base. And when you build such a knowledge graph with RDF graph model, you can infer new facts. When I say infer new facts, let me give you an example. We can say Socrates is a man, all men are mortal. These are two statements. When you put these two statements into a knowledge graph with graph RDF model, it can deduce the new fact, which is Socrates is mortal too. It deduces a third fact. And that is one of the major things that can help knowledge graphs with LLMs. Now, quickly, a visual example of what is a knowledge graph, right? Take a look at this picture where we are representing shoes. Shoes are represented by the colors, by the type or the style, right? This is a plain graph, but this is not a knowledge graph. This is just a graph which is connecting different things. If I take the same data and overlay ontology and taxonomies on top of it. Now, don't be scared with the words ontologies and taxonomies. We use ontologies, taxonomies implicitly every day. We just don't realize it. When you bring in the shoe ontology and link it to your data, and bring in what is called a color taxonomy, link it to your data, suddenly your data has become highly enriched. Now, your question would be, where do I find shoe ontology? Where do I find taxonomy, right? Well, these ontologies are just like public data sets, open data sets. These ontologies are openly defined by different organizations, by different consortiums. There are a lot of different ontologies like this, from sports ontology, food ontology, Financial domain has its ontology called FIBO, with a lot of the very big organizations use it. And these taxonomies are also highly available. And these ontologies and taxonomies can also be represented as graphs. And they can be very easily connected to your instance data. Once you have linked that ontology and taxonomy to your instance data, your data suddenly becomes enriched. And now you can quickly do graph traversals, graph paths, go through the graph paths and figure out new relationships. For example, if you had the data on the left-hand side, and if someone was asking you, how or show me shoes that are warm-colored shoes, right? You would not have been able to answer this unless someone wrote a stored procedure or an ETL code which classified bright crimson and a set of other colors as warm color. But because you integrated a lot of the data from external systems as ontologies and taxonomies, now you can quickly find out what are the warm colored shoes available in my inventory. Another example, we have all eaten pizzas. Pizza has different ingredients. Ingredients come from different parts of the world, and it can be delivered to your house through certain means. So this is what a graph looks like. You can, on top of this, again, overlay food ontologies, where each of the ingredients can be easily connected to the different food items, food ingredients. Now your graph has become enriched, and you can quickly find out if there is any component in my ingredient for which there is some kind of an allergy to someone. If you did not have this, you would have to write some ETL code or stored procedure code to do that logic, that deduction. That is available in a knowledge graph once you integrate these kind of ontologies. And here the example was about a food ontology. So basically, knowledge graphs need three components: a graph database to store the connections, the nodes, the relationships, the semantic metadata that is describing these nodes, their attributes, their characteristics, and then ontologies, which help you to enrich your data. And these ontologies typically can be very domain specific to the domain your business is in. So now let's see where knowledge graph fits into an enterprise, right? In a bigger scheme of things. Let's break this up a little bit, where let's focus on the center, where you have the enterprise knowledge graph, which consists of enterprise's own ontologies, schemas, taxonomies, the domain knowledge, reference data, all that. On the left is where you are connecting to different unstructured data through different methodologies and building what is called a content hub, which is semantically enriched with the metadata. And on the right-hand side is where you are bringing in structured data that is residing in structured or semi-structured data that is residing in relational databases, data that is residing in document databases, or data that is residing in data lakes or data warehouses. And you build what is called the semantic data fabric. And that's one of the reasons why, if you look at some of the Gartner papers or some of the design internals of data fabric-based solutions, you will see internally a data fabric is powered by a knowledge graph because it brings in a lot of semantics, because it has the context associated with the data that is coming in from different sources. So this is how a conceptual model of, or this gives you a big picture of where a knowledge graph fits into the enterprise scheme of things. So how do knowledge graphs provide context, right? If you take a look at this statement, Paris Hilton stayed at Hilton Hotel in Paris. You, me, human beings who know about Paris, you know about Hilton, who know about Paris Hilton, can quickly figure out what the context is. But machines have a lot of challenge understanding. They can easily confound the first Paris to be equal to the last Paris, or the first Hilton here to the second Hilton. This is where context becomes very useful. And this is what this context is something that LLMs are complemented with by knowledge graphs to get more accurate answers, to get more factual results, and reduce the hallucinations. And this is done with graph RAG based approaches, which we will go into details a little bit more later. So this context, because we know Paris is a city in the country France, which is in Europe, this can be easily connected. The second Paris is connected to a geographical location, while the first Paris is connected as the first name of a well-known celebrity, right? This is what the context, which is this data, the first Paris data is coming from a totally different system. The second Paris context is coming from a different system. And the knowledge graph has sort of connected them together to give you a broader context, more enriched data with the examples that we saw in the previous two slides. So the context with Graph Foundation, with ontologies, taxonomies, helps you to provide semantics. And graph-based approaches can help you in your data management practices, from data governance, which, from access controls, from policies, which can be decomposed into different granular entities and then linked. It allows you to help track lineage as data flows through a system. And this is a whole thing around linked open data, where data is linked across different systems. Entities are linked across different data systems, and that gives you capabilities to do sort of a needle in the haystack kind of a search, or help you to do use cases like custom entity 360. The other aspect of knowledge graphs, especially knowledge graphs developed with the graph RDF model, is helping you to disambiguate one entity from the other, where we help to disambiguate this Paris from this Paris because of context. And these are some of the use cases that, these are very high level use cases of knowledge graphs, from an architecture pattern where it's used in data fabric. It is used to build your domain knowledge graph, where it is the center in one of the earlier slides. It is used in generative AI with graph RAG, and plain graph analytics, where you're trying to find out, how do I go let's say with a GPS from one place to the other? Your graph algorithm figures out the path. That is a lot of graph analytics. And then the semantic content hub, where we showed in the left-hand side what the knowledge graph was helping you to build with unstructured data. And these capabilities allow you to do a lot of use cases around, let's say, customer 360 or any entity 360, patient 360, employee 360. Our product is used a lot in drug discovery, because drug discovery, for example, a lot of the information is spread out, is scattered across different data sets. And knowledge graphs help you to connect the data sets to figure out how one thing can influence other, how different proteins interact, how different proteins affect different genes. These kind of things are mapped into a structure. And then a lot of connected infrastructure, where how one infrastructure component can affect others based on certain capabilities. Our product is used a lot in risk management and compliance in the insurance industry, in the financial industry, to figure out how certain rules can affect compliance issues, risk management issues. And though this is a discussion on LLMs and knowledge graphs, don't confuse that, LLMs or knowledge graphs can only be used for LLMs. Knowledge graphs can be used, as I discussed earlier, in a lot of different things. A lot of you must have heard about the JWT telescope, right? JWT telescope was tested with digital twins, and digital twins under the cover use knowledge graphs because they need a very good granular representation of the concepts, of the semantics, how one thing can affect other. So there is a host of use cases for knowledge graphs, and this mind map just shows some aspects of it. You see here, from data management to content, unstructured data management, to the whole knowledge management, LinkedIn, for example, we use LinkedIn every day. LinkedIn under the cover uses skills ontology, and they have their own knowledge graph that helps you to manage different skills, competencies, and as things change, they update it. So in short, knowledge graphs provide you a central hub to bring in data together. They solve a lot of the ambiguity issues, like we saw with the word Paris. Data is represented consistently and unambiguously. One of the major areas where knowledge graphs help you is in the data integration. As I was telling the last 20 minutes, is integrating data, not just integrating plain integration data, but semantically integrating. We know data integration is a huge area, right? Huge industry. Most data management companies tend to go into the data integration bucket, right? And data integration consumes so much time, resources, and finance for a lot of companies. Knowledge graphs help you to semantically integrate data that resolves ambiguity issues for you automatically. So now let's come to the core of the topic, which is knowledge graphs and LLMs, right? We know AI is in the mind of CXOs for all organizations, right? And a lot of them do agree that there is a challenge related to the trustworthiness of answer coming from LLMs, especially if you are leveraging it for data management and analytic practices, right? Our CEO often says that if you're using LLMs for data analytics, you better get a liability insurance, because there are a lot of cases where you don't get results close to even 80% correct. So a lot of organizations are looking to leverage LLMs and Gen AI for data management practices, but they run into challenges and concerns around accuracy, bias, hallucinations, and things like that. Provenance, one of the things which we have done, which I'll show you just a screenshot of one of the demos that we have done, is with LLMs, you never know where it is getting the answers from. But we have implemented with knowledge graphs ways of doing RAG, where it gives you a traceability, a provenance of where it got the answer from. It can be quickly pointed to the original source document. We have seen also a lot of news last 18, 20 months since ChatGPT burst on the scene around how LLMs can be leveraged with knowledge graphs. And it's a symbiotic relationship. It's a symbiotic, synergistic relationship between LLMs and knowledge graphs. And we'll see examples of that. So we know LLMs as being used in a lot of different use cases, from content to to generating content, to also understanding content to a certain extent based on the context windows. But we know that LLMs cannot really give you accurate information all the time. And this is where knowledge graphs come and help to unlock the true potential of LLMs to bring in factual accuracy and meaning because LLMs are built, because knowledge graphs are built with contextual and semantic data, right? This just is another way of showing where knowledge graphs and LLMs, lying on two different sides, can be bridged together with the pros and cons of each of them. And here is a mind map that really shows you what can be done with LLMs and knowledge graphs, right? LLMs can be enhanced with knowledge graphs by providing grounding context. We know about the grounding information that LLMs need, and the solutions around them are based on RAG techniques. We developed this approach called graph RAG, where graph RAG provide you grounding context. LLMs can be enhanced with knowledge graphs, where knowledge graphs can hold proprietary data, domain-specific knowledge graphs. Knowledge graphs can provide an LLM that is enhanced with knowledge graph can provide you provenance, linkage to the answers, where it's getting the answer from. And that, to a certain extent, helps you in explainability. However, knowledge graphs can also be used to leverage can leverage LLMs to bring in multiple capabilities from enrichment. We know LLMs are very good content machines, right? Where they can easily understand content and generate events or extract out events from an unstructured data, extract out entities. They can extract out that Paris, that sentence we saw, right? Paris Hilton stayed in Hilton Hotel in Paris. It can extract out the two Paris and identify it as an entity. It can extract out that entity Hilton Hotel. But where it runs into challenges is to distinguish between one Paris and the other. So it can help in entity extraction and relationship extraction, generating descriptions for these entities, and classifying these entities. One entity is a person, another entity is probably a location. Knowledge graphs are also being helped by LLMs to do things like generate a graph query, right? Text to query, summarizing query results, explaining a query, explaining a schema. All these things can be easily done with LLMs now when applied to knowledge graphs. You can also generate, this is a question I get all the time from a lot of prospects that we meet, is, are we at a stage where LLMs can automatically generate knowledge graphs? The answer is no, not with 100% accuracy. There are certain cases where you can generate a seed knowledge graph with prompt engineering, given an ontology, given a schema. Now, LLMs are not good for something called entity linking, and I have a slide showing you that. This is something that LLMs are not able to do yet. Depends on how fast the technology is going, whether it will be able to do it or not. And that is where knowledge graphs come in. And what is entity linking? We'll discuss about it. So this is a quote from Gartner, I think about a year back, where they also stress the importance of knowledge graphs with LLM-based solutions. I think we don't need to go through this slide specifically. This is all discussed earlier, which is how LLMs, when they need grounding context to be successful, useful, and reliable in terms of accuracy, in terms of factual accuracy, they need knowledge graphs to limit their hallucinations, to provide governance through provenance and lineage. Now, we saw this particular diagram earlier, and this diagram now has additions of where an LLM can help in this overall scheme of things. We have a lot of POCs going on with different customers who are testing this out. Can I develop chatbots with enterprise knowledge graphs for my specific domain, where you can quickly do natural language query that gets translated into a knowledge graph query or a graph query to bring back the results to you based on your knowledge graph, based on your domain knowledge. LLMs, as we said earlier, can parse documents and understand and extract out entities, events, relationships. That is where LLMs help. LLMs also help you to generate relational queries, understand the queries, explain the queries, understand the schemas. So this is where LLMs can help with knowledge graphs. We, over the last year and a half, we have sort of remodeled and added a lot of new capabilities within our graph database engine. We have a graph database engine called GraphDB. We have an IDE-based tool called Metadata Studio that is mostly meant for working with unstructured data. And we are leveraging LLMs to help in each of these, to talk to your graph. We integrate with LangChain in Python to build GenAI-based applications with graph databases. And we have also developed capabilities to do entity linking with semantic tagging, semantic annotation, and information extraction. We have added these capabilities into our product stack for LLM integration. Now, coming back to the last part, which is around graph RAG. We have heard about RAG, right? Where R stands for retrieval, A is for augmentation, and G is for generation, where a lot of organizations use vector databases to build their RAG application, where they want the LLMs to work with proprietary data. So what is graph RAG? Graph RAG, again, graph RAG is a term that a lot of different companies use. They have their own. There is no standard definition. What we use, what we call GraphRag, is a knowledge graph enabled retrieval part for doing RAG. And this knowledge graph provides LLMs the context, the metadata, and semantics that help to answer a given user query. It augments the user query with the context that it gets from the knowledge graph. And oftentimes, it can use semantic reasoning in the knowledge graph. Reasoning meaning that example that I gave about Socrates is a man, all men are mortal, how it reasoned out and figured out that Socrates is mortal too. With semantic reasoning to enhance and give more data to the user query so that the user query can be answered correctly. What knowledge graph provides with RAG is it captures relationship of entities across these chunks. Now, why do we need graph RAG? We need graph RAG because plain RAG based on vector databases runs into a lot of limitations. It struggles to connect the pieces together, especially when in plain RAG you chunk your data. And if your answer cannot be found in one chunk, it causes problems related to accuracy. If the same entity is mentioned across two different chunks, knowledge graph will have the link. And that is why knowledge graph will be able to give you much more higher accuracy results when you do the querying. We experimented it with this. We took our own website, OntoText's own website, and we created, which is full of information around case studies, white papers, blogs, other textual data, and we built a knowledge graph with our own tools. Then we did a query asking it to give us, we did an NLQ type of a query, natural language querying, to ask it, show me who are OntoText customers in the US government or US government agency. We have NASA as one of our customers. But even though the data NASA is there in the data itself, the plain RAG could not figure out that NASA is a government agency. While because we were using a knowledge graph, which is enriched with ontology, NASA is a government agency, and that part is encoded in the graph RAG embedding that allows it to come back with the right answer. So plain RAG is okay for unstructured data. It cannot work with structured data. So these are some of the limitations of plain RAG. And this is where graph RAG comes in and helps to build much more accurate contextual, gives you contextual based answers with explainability and provenance and interpretability in terms of where it got that answer from. So when do you use graph RAG? When you have both unstructured and structured data, when your question is spread across the different chunks, when plain RAG fails to give you the right results, when you need explainability and provenance, when you need much more deeper understanding of your data rather than just the understanding of the words and their embeddings around it, right? Especially if you have aggregate type of queries where your answer is actually not very evident in one chunk. It is more higher level of abstractive type of questions where you may need to get answers from, for example, questions like this, where the answer may not be found directly in one chunk. That is when graph RAG based technology with knowledge graphs help. So how does graph RAG work? Right. Now, we were talking about RAG, where this is the retrieval part. The R stands for the retrieval. Now, there are three different ways of doing retrieval, right? A full text search based, which we already know, with engines like Lucene, with engines like Elasticsearch, Solr. They can do full text retrieval based on keywords, Boolean values, and all that. There is vectorized methods, right, where we take different words and we vectorize it. We take different sentences or paragraphs, vectorize it, and do similarity-based testing, proximity-based or nearest neighbor-based test retrieval, right? And then this is what we do with this semantic-based approach of retrieval. Now, OntoText's knowledge graph already has these capabilities, vector and full text. We added semantic-based retrieval capabilities with the graph rag. So now our product has all these capabilities. And the next version of our product is coming up with capabilities to leverage either one or all of them through agents. When you give it a natural language query, it will do all these searches or a combination of them from a retrieval purpose and get back to you with the best answer. And this is typically the diagram, right? A user gives you a query, which is called a prompt here, and you get the context. You have to enrich the prompt with some context. And the context is enriched with some retrieval technique, which is either a similarity-based, which is through a full text connector, or you go to a vector database, or you go to a combination of graph and vector. You enrich your question with the context, you pass it to the LLM and get the answer. That's the usual path, right? And these are the three different graph rag patterns that we found were most useful. And if you look at it closely here, each of them corresponds to this particular picture. So I'll flip back between these pictures so that you get a better understanding. When you use graph as a metadata storage is when you use this part of a knowledge graph, which is more domain specific, which is very specific to your domain of expertise. The next is, the graph metadata store is actually this part where you are querying the graph based on unstructured data that is coming from your own domain's data, right? Let's say, for example, the drug discovery. The graph as an expert, which is the domain knowledge, is this part where all the domain knowledge, reference data, your own domain ontologies are all sort of mapped here in the knowledge graph. And then the last part is the data fabric part where you are querying the data, or you want to do graph rag based on your data that is in your structured data across data lakes, data warehouses, relational data stores. Now, each of these RAG patterns have different benefits. You can filter your data not just on something, but on your metadata. It provides you explainability. Graph as an expert gives you much richer results because it's enhanced with a lot of the domain-specific data, which something a plain vector database would not be able to do. And then graph as a database where you are getting a lot more factual information from your relational or from your data lake related data stores. And this is how each of them work, each of these. And I have a diagram that shows how this basically works. The last two approach require what is called entity linking, where you have to link, like we saw in one of the previous examples, Paris. One Paris was related to a geography, one Paris was related to a person. That entity disambiguation through entity linking is something LLMs cannot do. And that is where we innovated with a lot of work with our entity linking capabilities. And I'll show you the results in the next slide, where you can detect these entities and then connect them to the right IDs. Knowledge graphs use what is called IDs. Just like every website has a URL, like you say CNN or BBC, they have an associated URL. Similarly, each entity has a URI, Uniform Resource Identifier. And that is what entity linking does to figure out which particular entity is connected to which ID. And we developed our own technology for doing entity linking which performs better than what Google does on Wikidata. Wikidata is a very rich knowledge graph with about how many million 100 million concepts and entities that are there, and you can link it to that. So we developed algorithms and a system to do entity linking at a very high throughput and very low latency. The last couple of slides, we'll just look at some of the higher level architecture diagrams about how we implemented NLQ, natural language querying, with that is talking to your graph, where you can pass the ontology to the LLM that can generate Sparkle queries. This is our query language that can generate, and this is not our proprietary language, it's a web standard language that can generate Sparkle query to query the knowledge graph. That knowledge graph is encoded. The knowledge graph is encoded and embedded through this open API, OpenAI's retrieval plugin connector that creates embeddings and stores it into the vector database. We do the entity linking, and then that is passed to the LLM to get the answers back for a given query, and that is the result. This is a screenshot of one of our application, a demonstrator. For those of you who are interested, please connect to us and we'll help you show this. As I was saying earlier, we took our own website data, created a knowledge graph, and then created a natural language querying with faceted searching. And this faceted searching is generated automatically because the facets, the concepts, they are all part of the knowledge graph. And you can now interact with your knowledge graph through natural language querying. So you can do search, you can do navigation, querying, and each of the answers has a link in terms of where that answer came from. And we leverage, again, we use this technology, we use LLMs to get the answer, but with our own proprietary knowledge graph, you get provenance. And then you also get recommendation, graph-powered recommendation in terms of, okay, you search for this, but these are other things that you can take a look at. And this is the architecture for it, where the user query comes through, applies the filters, it goes through our different searching or the retrieval techniques, uses the vector database where the knowledge graph has been already vectorized or embedded and stored here, and then uses LLMs to answer the query and get back all the results with explainability, with the recommendations and the answer. As you saw in the previous, this is the answer, these are the answers, these are the explainability, the provenance aspect, and this is the recommendation to do that. We have a tool called OntoText Metadata Studio, which I said earlier, which is used for working with unstructured data to create your semantic annotations, semantic tagging. You create a knowledge graphs from unstructured data, and we have enhanced it extensively by integrating with it the powerful features of LLMs, from zero-shot classification with well-known taxonomies, where you can pass in a taxonomy and it can detect an event or detect a entity. With relation extraction, it can also help you to enrich your taxonomies, or even in building certain ontologies from ground up. So that's it from a presentation perspective. There are a lot of links here which you can take a look at. And if you have any questions, you can either reach out to me, sumit.pal@ontotext, or you can send an email to info@ontotext. Thank you so much. So I see a question here from Brian. Brian, your question is, you mentioned that RAG alone couldn't find NASA because it didn't know NASA was a government agency. Let me increase the size of this. Okay, just hold on. how does this compare to a chain of thought approach where the RAG might search for context and ontologies before generating? Yes, chain of thought is what we are using in our next generation capabilities, where you can do multiple steps of asking through an agent or asking through a system, where you can ask about these different questions in breaking it up into different pieces, right? But the challenge here was that it did not know that from the data, it did not know that NASA was a government agency, right? That is what we found out and what we solved through the graph RAG approach. But through chain of thought, that could be another way of solving it.
Awesome. Thank you. Fantastic presentation. Great content here. Thank you so much, Sumit. I do have some more comments and questions as well. The pizza example that you had, I think that really that was a great example of showcasing. Of course, we have ingredients from for the pizza, and you have people creating those ingredients and where they get shipped from. But then you had a really interesting connection, which is allergies and intolerances. So lactose intolerant individuals might not want to eat pizza because of the mozzarella on pizza. And just having a connection like that really shows the power of graphs. I think it's really cool to see, because then you can search for what food might I not enjoy as lactose intolerant. And it would show pizza as one of those examples just by saying yes, because it has mozzarella on it. We don't need to specify that pizza itself is has
Allergies.
yeah, exactly. So I really like that one. The question that I have, so you were talking about LLMs enhanced with knowledge graphs. So looking at chatbots like DocsBot, Qualified, and so on. And how would you? I know you talked about this enhancing a knowledge graph with an LLM. So could an LLM then be used to create nodes and the connections, or how would that work?
LLMs can be used, and we are doing it, is when you give it an unstructured data, right, a sentence or a paragraph, it can extract out the entities. Like it can identify your name, my name, and let's say we are connected through something, right, through LinkedIn, right? It can from the given text, it can do entity extraction. And then when it does entity extraction, if it's once it's done, it can figure, if the data is there in the sentence, it can figure out how they are connected. They may be connected with, like, say, is a father of, right? Something like that, right? Or Sumit visited a country, right? Sumit is an entity, country name is an entity, right? It can do all that. But what it cannot do is what is called entity linking, where a country, let's say France, right, has a unique ID in the semantic world, right? It cannot connect to that particular ID, that this France is actually that ID, right? That part it cannot do. So LLMs, to a certain extent, yes, can extract entities, do relationships, but they are still not 100% accurate in that. There is always, but it bootstraps you to a certain extent.
Mm-hmm. Yeah, I think it's a really interesting topic, and we spoke before we started the presentation that I've been a big fan of graph databases for the past decade. And at the end of the presentation here, you talked about graph RAGs, and I'm currently doing a pet project. I'm documenting it on the Cosmos community forum, where I'm doing a pet project with OCR PDFs of Japanese video game magazines. And I'm putting them into what you called a vanilla chunky RAG. And the information that I get back is unsatisfactory, absolutely. I get a lot of hallucinations, such as Johnny Depp being a part of the video game development team for a bunch of video games in 2014, which is untrue. So definitely sounds like a graph database feeding into the LLM would be very beneficial here.
One of the ways in which you can look at it, yes, to solve it, absolutely.
Yeah, this has been fantastic. Thank you so much, Sumit. You have been a fantastic presenter. Really, really appreciate you being here today. Thank you, everyone who's watching, and keep an eye out for future events. We have webinars every week on Tuesday at 2 p.m. And we have a bunch scheduled already for the next coming month. So we'll see you there. Thank you all.
Yep. Thank you. Thank you very much.